Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Abhipray Sahoo, who holds a bachelor's from Rice University and a master's from Stanford in electrical engineering. How are you doing today?
Doing great.
Yeah, so thank you for coming on the podcast. So to get started, I wanted to ask what made you choose your major for your bachelor's degree?
Yeah, thanks for having me. What caused me to choose my major? So I majored in electrical engineering at Rice University. And in high school, I was good at a lot of different things, but particularly the things that interested me were physics. And specifically within physics, it was electromagnetic phenomena. Not that I was necessarily good at it, but I was just interested and I found it mysterious. And I knew I wanted to study something that touched on those topics. And on the other side, I was also interested in computer science as a very practical way of solving problems. So when I decided on a major, it was kind of a combination of those two topics, what was at the intersection. And I found electrical engineering to be right there, that touched on both of those topics from physics and computer science. So I'd say that the main driver for me was like my interest in those topics coming from high school. So I knew what I wanted to major even before coming into college.
Yeah, so what was your experience like while you were at Rice?
When I was at Rice, I was exposed to a very different kind of thinking than I was expecting. So, like I said, when I was in high school, I thought physics would be kind of like the driving force behind a lot of like how you think about solving electrical engineering problems. But the way that Rice tackled electrical engineering was different. They focused on a very broad, abstract way of thinking about electrical systems, just in the general sense of signals and systems, where you think about inputs and outputs and systems modifying inputs to produce certain outputs, but from the lens of those inputs and outputs being represented as signals. And so this very first course that I took at Rice exposed me to this kind of thinking, where you could break down a lot of different systems, including mechanical, electrical, down to very basic information centric view of how to think about engineering systems. And so, from an academic standpoint, I think that shaped the rest of how I thought about a lot of problem solving and engineering challenges that came up through my experience in industry. Yeah.
Yeah, so can you talk a bit about the internships you held?
Yeah. So beyond just like taking the courses at Rice, I also wanted to see what different um, opportunities there were in industry. So my first summer, I did an internship within a couple of labs at Rice. The first lab was doing research in wireless systems, and they were focused on basically prototyping a platform, or they had a platform with which you could prototype wireless systems. And my project was to explore fabric antennas, these antennas that were flexible and that you could put on clothing. And this was something that NASA was interested in. It was an antenna that NASA had produced for placing on astronaut suits. And so my project there was to characterize these fabric antennas, to provide clues into how it performs in various different conditions. And so that was one of the projects I did. The other project that I did had to do with creating an online course on Coursera. So I've always been interested in scaling educational content. When I was in high school, I took the very first Coursera class that was on machine learning. So it was back in 2011, 2010. And when I started at Rice, the professor there was also very interested in putting up the first ever lab course on Coursera, where people could buy these kits that had a bunch of electronic components, and they could string it together and learn electrical engineering through the practical lens of solving problems with real components. And so that was my other project. I helped this professor put together this course on Coursera, and it was the first ever lab course that you could sign up for and do it from anywhere in the world. And so that was the other project I did that summer. My sophomore year summer, I decided to see what software engineering would be like, and I found a gig in a hedge fund called HBK Capital Management in Dallas. The hedge fund itself is very small, and they had maybe a technology team of 15 or 20 people, and I interned in the team that was supporting quantitative finance and the traders that use certain tools. My project there was to enable some of these quantitative traders to use Python within their Excel spreadsheets. So I built on top of an open source project that allowed you to embed a Python interpreter within Microsoft Excel. And that eventually, the goal of which was to allow these developers to write Python and manipulate their cells in a very generic programming language that is Python. And so that was my second internship, which was very software focused. It involved a lot of C because Python, the interpreter is written, or there are versions that are written in Python, but the version that I worked with was written in C. And in order to get access to Python through Excel, you had to get down to that level. And so it was a lot of C, even though we're trying to put Python in Microsoft Excel. And so that was a really cool experience because after that, I also got a chance to present this at a conference, the PyTexas conference, where I got some more feedback on where to take this project. So that was a fun software engineering internship. I liked it enough that I knew I wanted to do more software related projects. And so the following summer, my junior year summer, I took on an internship with Google. And this internship, I specifically chose to be in Zurich, Switzerland, just as a way for me to also experience another country and see what work life was like there. And so I did that for 3 or 4 months, and I worked in the YouTube team in Zurich. That at that time they were trying to sell movies and TV shows on YouTube, and they had a lot of trailers that companies that wanted to sell movies or TV shows would provide them. But there were also a lot of movies and TV shows that just did not have any trailers at all or previews. And previews are kind of really good way to get people to buy your content. And so my project there was to automatically generate these previews of TV shows and movies. And so part of that was to write a lot of code that would process a lot of videos, like a lot of videos of movies and TV shows, and do some transformations to extract the most interesting content within movies and TV shows and to present them as previews. And the way that I thought about it was to also do some image analysis to extract text and kind of find interesting text to also provide. And that was kind of the main project that I did there. It was a very interesting experience being in Zurich itself. Um, their their work culture, I mean, it is Google is an American company, and the work culture is very similar there. But a lot of the engineers there were European, and they seem to have a different perspective on work-life balance, which was that they valued it more. Um, and overall, just being in Zurich in the summer was a lovely time. Just going out to the lake to have lunches was a fantastic experience to also bond with your coworkers and other interns. So that was my last internship that I did. Um, and after that internship, um, I had already done my senior design project my junior year, and my senior design project was something that I felt passionately about. And as soon as I'd done that internship, the sponsors for that senior design project started a company. And so when I went back to college, I started working part-time for the first semester after on this project, which then turned into a full-time job for the next 5 years.
And what kind of work were you doing there?
So for my senior design project, I was working on a vest that had a grid of vibrating actuators, um, whose goal was to provide a device for sensory substitution. So sensory substitution is this idea of sending information to the brain through an atypical sense. So in our case, we were concerned with sending audio information to the brain via the sense of touch through a vest form factor. So the vest form factor had a grid of 32 vibrating actuators, and there was a microphone that picked up sounds in the environment and then mapped them to vibration patterns that represent those sounds. And the idea here is that through training, a person wearing this for long periods of time can build an awareness of sounds in the environment and eventually speech. And so this was a very powerful idea that I thought had lots of merit, and I thought I should devote some of my um, time towards this project. And so when we started the company, we went out and tried to figure out, from three directions. You need technical feasibility, you need business feasibility, will people buy this? And you need scientific feasibility. So we had many problems at hand that we were trying to solve simultaneously. And over the course of many years, we found success in certain aspects of the scientific portion of it, where certain hard of hearing people were able to interpret sounds of speech through the vest. And then we also had luck with technical feasibility, where we could do certain clever things in representing sounds that are relevant to the user while minimizing noise in the environment. And on the business front, we were able to do a lot of user research and figure out that a vest form factor might not be the best for consumers for many usability reasons, such as washability and care and maintenance, as well as wearing something bulky. And so the very first product that we came out with was approximately 5 years after I started there. It was a wristband that had, instead of the 32 that was on the vest, it had 4 vibrating actuators and a microphone that picked up sounds. And we were able to design algorithms that were tuned to useful sounds in the environment, such as dogs barking, your microwave dinging, your doorbell. or some people even reported being able to use it for lip, I guess, like reading other people's lips, um, and enhancing their speech comprehension through that. So that was my first gig after college.
Yeah. So, when did you do your master's at Stanford?
Yeah, so 3 years into this job at the startup was called Neosensory. 3 years into this job, I'd already put on a lot of different hats. I was building mobile apps on Android as well as eventually iOS. I was helping with the backend to do things like telemetry. I was doing embedded software to actually run the algorithms that take the sounds and map them to vibration patterns. Um, and the in doing all those, I realized my the way that I could best contribute to this team was through focusing on the embedded software piece and the algorithms to represent sounds. And the more I dug into it, the more I realized that there are certain theoretical foundations that I was missing. And I thought it was best to gain that through school. And so the startup had started in Houston, but then we moved out to the Bay Area, San Francisco Bay Area in Palo Alto. And one of the founders had also become a professor there, David Eagleman. And that was also part of the reason why we moved to that area. And because Stanford was just down the street, I could, go to work and then leave for a few hours to attend classes. And so I applied to Stanford and started this master's program with a focus on theoretical foundations around statistical signal processing, information theory, deep learning, and other related things that would support my work at Neosensory. And I cannot recommend it enough. I think just the difficulty of it was very high, just trying to juggle work and school. I spent a lot of hours doing both, and I took knowingly very hard classes that would challenge me. But through all of that, I think by pushing myself, I think I gained enough foundational knowledge that even though I don't remember a lot of it now, I can go back, look at it, and quickly get up to speed again. And a lot of the stuff that I learned is very general. Like a lot of it has to do with generic math and signal processing that's applicable in a lot of different fields. The other great thing that came out of my time at Stanford was some research that I did with this octogenarian professor named Dr. Bernard Widrow. He is the founder of adaptive signal processing, which was the precursor to neural networks as we know them today. So he popularized the LMS algorithm. He created that with Ted Hoff, who was one of the early employees at Intel. And they came up with a way to essentially train a single neuron from their perspective, and they applied it to signal processing very successfully into a lot of applications, some of the earliest ones being early modems and early communications equipment. And so he was, at the time when I was at Stanford, very interested in biological neural networks. He had, through his research, figured out some very basic paradigms that could be applicable to artificial neural networks, the core of which was this idea of homeostasis. Homeostasis is where a certain system is trying to regulate to reach a certain set point. Your body does this all the time with things like your temperature. It has a certain temperature that it wants to achieve, and it does various things to achieve it. And so he discovered that there is a certain homeostasis in biological neurons that is interesting. And so the two of us started exploring what that model could look like from like a very mathematical standpoint, and see what emergent phenomena could come out of it. And so it was very fascinating to dive into this world of homeostasis and apply that to artificial neurons, and then from artificial neurons to other generic phenomena in the human body. And so he was, over the course of a couple of years, started writing a lot of the stuff that we've been doing research on. And I helped him convert this into a book. The book is called Cybernetics 2.0, and it's all about this idea of using homeostasis to understand how neurons might learn and how various parts of your body achieve homeostatic regulation.
Yeah. So what did you do after finishing your master's and your time at Neosensory?
Right. So after Neosensory, I spent 5 years there. We launched a product. I'd seen it go from 0 to 1. Stuck around for another 7 months to support any um, any issues with the product through factory or from customer feedback, and roll out new features. I switched jobs to Apple to work on health sensing for the Apple Watch. It continued my theme of trying to work on products that help people from a very like health centric way as much as possible. And so Apple Watch at the time was really starting to get big into health sensing, being able to sense through its sensors like the accelerometer and the PPG sensors that detect various signals for how blood flows under your wrist, temperature, and so on. And so I was very interested in contributing to that effort. And so I worked on those set of features at Apple for 3.5 years. Most of my time there was spent building the firmware platform that supports all these different sensing abilities simultaneously, and making it all the data and algorithms available to end customers as much as possible.
Yeah.
And so, yeah, so my experience at Apple was fantastic. I learned a lot. It's a very different way of thinking about problems, where at a startup, you're really trying to just launch a product and get your very first customers. Whereas working on the Apple Watch, which had already been on the market for many, many years, and trying to I'm trying to contribute to an already big project that reaches millions, tens of millions to hundreds of millions of people around the world. It's a very different experience. I think you have impact. You may be doing very niche, small things, but the scale of the impact is magnified by the number of users. And so different modes of thinking.
Yeah. So what's your current job?
So my current job is I'm a firmware engineer at Tesla. I switched over roughly 7 months ago. There I work on the part of the car called the drive inverter that sits between the battery and the motor. It's what controls the motor. It draws power from the battery and puts it in a form that allows the motor to spin based on what's asked from the accelerometer, the accel pedal, as well as any other inputs that go into it, such as autopilot. And so my current job is to support the drive inverter. Specifically, I'm focused on fault response. So there is because it sits at the very core of the car that drives the car, and it controls a lot of energy flow. The chances of things going wrong are not high, but they're a possibility. And my job is to predict them and to catch them before they happen and to appropriately respond in those situations. And so it's a very safety critical component, and fault response is a core part of making cars safe and reliable.
Yeah. So for my last question, I wanted to ask if you have one piece of advice for someone who's still in high school wanting to follow a similar career path as you.
That's a great question. I'd say one piece of advice I have is to pursue whatever you pursue with genuine curiosity. If there are things that motivate you that aren't coming from within, if that makes sense, if you're not genuinely curious about a topic, you may not go far with that endeavor. And so my recommendation would be to spend some time thinking about what it is that truly makes you passionate, and do that, even if other people tell you that you may not land a good job or you may not have a good successful career out of it. If there is something that is technical that you're really interested in, pursue it, and I'm sure things will turn out okay.
Yeah. So thank you for joining me on the podcast today.
You're welcome. Thank you for having me.